Hello everyone, I am Haiying Che from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we will discuss data cleaning technology. Data cleaning technology is used to clean the data, make it well organized for further analysis. Here we discuss three kinds of problems: repeated record cleaning, missing value cleaning, and eliminating noise data. First, let's look at the repeat record cleaning. Duplicate records will lead to erroneous analysis result. So it is necessary to remove duplicate records in the dataset to improve the accuracy and the speed of the analysis. So what are the causes of duplicate values? First, integrate data from multiple data sources will result the duplicate values. And second, when you input, some data is input repeatedly. So duplicate values should be combined after inference. First, we can delete completely duplicate record. Or when merging different tables, some extra attributes, such as time, need to be added. How to find the duplicate records? First, it is necessary to compare the related attributes of two records according to the similarity of each attribute and the weight of the attributes. The similarity of the record is obtained. Then, if the similarity value exceeds a certain threshold, it is considered as a duplicate record. Now let's look at the missing value cleaning issues. The cause of missing value could be equipment abnormal, or when entering some data is not taken seriously or not entered. Missing values must be handled and added. We can ignore this record or use default value to fill the missing value, or use the average of similar samples to replace the missing value, or we can predict the most likely value of this missing value. The third data cleaning technology is eliminating noise data. Data noise can be eliminated using different methods, such as binning, split bin algorithm, or clustering algorithm, or regression algorithm. First, let's look at binning algorithm. Binning method means put the data to be processed into some boxes according to the certain rules. Examine the data in each box and use a certain method to process the data to get a value for each box separately. In binning method, box is a subinterval divided by attribute value. If an attribute value is within a certain subinterval range, it is said to put the attribute value in the box, which is represented by this subinterval. The main issues of binning are how to divide the box and how to do data smoothing. That is, how to smooth the data in each box, which means use what method to decide the value to represent each box. In the example here, there are 4 different bins: gray, yellow, green, and purple. Each age value is put to certain range, like age 10 is put into the range from 10 to 16, the gray box, and so on. The ways of how to sort the record set before binning include equal-dash binning, equal-with binning, or user-defined interval binning. Let's look at them one by one. The equal-dash binning method. Bins are divided according to the number of rows of the records. Each bin has the same number of records, and the number of records in each bin is called the weight of the bin, also known as the depth of the bin. In this example, we have 16 records, and we decide the box depth is 4. After binning, we have 4 boxes result, and each box contains 4 records, which is the depth of the box. Equal-with binning method evenly distributed over the entire attribute value interval. That is, the interval range of each box is a constant called box width. In the example here, set the interval range, the width of the box, to 1000. Then the result is also 4 boxes, but the records in the boxes are different from the equal-dash bin method result. After binning, we should choose a value to represent the boxes, which is called smooth. There are mainly 3 ways to smooth: smooth by average, smooth according to the boundary value, and smooth according to the median. Smooth by average is to average the data in the same box value and replace all the data in the box with the average value. And smooth according to the boundary value is to replace each data in the box with a boundary value with a smaller distance. Smooth according to the median is to take the median value of the box and use it to replace all the data in the box. Second way of eliminating data noise is clustering algorithm. Now let's look at the clustering algorithm. Cluster is a collection of data objects, and all the objects in the same cluster are similar, and objects in different clusters are quite different. Clustering means grouping a collection of physical or abstract objects into different clusters, finding and clearing those outliers values that fall outside the clusters. These isolated points are regarded as noise. Unusual data can be discovered through clustering analysis. Similar or adjacent data are aggregated to form cluster, and those data objects outside these clusters are naturally considered as abnormal data. The advantage of this method is we can directly form a cluster and describe the clusters without any prior knowledge. The third way of eliminating data noise is regression algorithm. Now let's look at a regression algorithm. Regression means finding the pattern of change between 2 related variables, which are x and y in the diagram, and smooth the data by fitting the data to a function that is using the fitting function to smooth the data. Regression method could be linear regression or non-linear regression. Linear regression, which is a simple regression, use strict line modeling to treat one variable as a linear function of another variable. For example, in the equation y = ax plus b, where a and b are called regression coefficients. And the coefficients a and b can be obtained by the least square method. In this session, we generally introduced data preprocessing. Thank you for your attention. If you have any question, feel free to contact me.